Welcome back, chemistry fans. Today, what we are going to do is our day 31 warm-up. So let's jump right into it. It's a lot of practice with nomenclature, and you need to make sure you get all these right. Practice them, because if you don't do well on this, you will be not doing so well on the test. Okay, so the first one, we're writing the name. And what we must do is we must first analyze, where is this element in terms of its location, or in comparison to its location on the periodic table. So if you will look at my periodic table here that I've got open for you, what you're going to notice, sorry, so if I can erase some of this stuff that's on here, is that calcium is on the left of the periodic table. And so what that's implying is that we have a charge of +2 for that calcium. So let's put that to effect here. It is not a transition metal. It is not an acid, which is what we're going to learn about today. But there is a polyatomic, because there's more than 2 elements here. But first off, we're just going to write down our calcium. Now, no Roman numeral. It's not in the middle of the periodic table. Now I got to go and look up off of my chart of polyatomic ions. And I find that that's name is acetate. It has a charge of -1. Those 2 charges got crisscrossed and it balanced out, but we don't have to do that. All we have to do is just write a name. Calcium acetate. Okay. Now, number 2, technetium. Let's go find where technetium is. Well, we already know it's in the middle because there's a Roman numeral for it on the name of it. So we're going to write down our symbol, Tc, and it tells us what the charge is. It's +6. Phosphide, IDE, tells us it's the element by itself. It's not a polyatomic ion. It would be phosphate if it were polyatomic. It's phosphide. So we got to go and figure out what's the charge of phosphide. On one of your periodic tables, you will notice that the charge of all the elements in this column have a charge of -3. So what we will do with that is we will take those 2 charges up in the air and we will crisscross them down. And we would see that we have a Tc3P6. That needs to be reduced down. My final answer would be Tc1P2. All right, now coming up with the name on number 2. Neither of these elements are polyatomic. There's no parentheses. There's only 2 elements. And I know you're saying there's 3 atoms. That's right, but there's only 2 elements. So with that said, we are not going to use a Roman numeral for this name. So it's just potassium is the first element. And we will go and look up that this is tellurium. Tellurium. So potassium telluride. Ooh, I got the wrong suffix on there. IDE is what that needs to be. Tellurium becomes telluride. All right, number 4. Notice we've got prefixes. So that means both carbon and chlorine are nonmetals, and we can verify that. When we look on the periodic table, I've got carbon and chlorine. Both are to the right of the nonmetal metal staircase. So that means that they needed these prefixes. The prefixes tell you how many atoms there are. Carbon, 4, tetra means 4, chlorine, the hepta means 7. No need to reduce this. All right, number 5. I've got niobium. Niobium is in the middle. Now, I don't know that just looking at this balanced reaction. I've got to go and look on the periodic table, element number 41, niobium, Nb. It's in the middle, so that 4, it needs a Roman numeral. What will be the Roman numeral is the second number gets crossed backwards. I verify that the oxygen is correct at a -2. So therefore, my Roman numeral will be a 5. Oxygen becomes oxide. Niobium 5 oxide is the name. It needs a Roman numeral because it is a transition metal. Formula for strontium sulfate. It ends in ATE. That is a signal that we are dealing with a polyatomic ion. I will go and look up. Sulfate has the formula SO4. It has the charge of -2. Strontium is Sr. It has the charge of +2. Those two charges are opposite and equal. Oh, and by the way, how did I know that strontium has a charge of +2? It's in this second column, right below calcium. All elements in the second column have a charge of +2. I have two elements, two particles that have an equal and opposite charge. So you could crisscross them down, but you should just notice that they get canceled. I could put parentheses around it if you want. It's balanced out. All right, gallium oxide. Ga is the formula for gallium. O is the formula for oxide. Let's go and look at what their charges are. Gallium is in the same column as aluminum. All elements underneath the column, underneath the staircase, have a charge of +3. Oxygen has a charge of -2. So I've got +3 and -2. Those two charges are opposite but not equal. So I'm going to crisscross their charges, and I'm going to end up with Ga2O3. Now, as far as the name of this compound, that's nitrogen, that's selenium. Let's go and see if nitrogen is a transition metal. It's not. It turns out nitrogen is a nonmetal. And so is selenium. Selenium is also a nonmetal. So when you see two nonmetals together, that means you're going to have to use prefixes. What prefixes will you use is pentanitrogen. Don't change the suffix. And then we put in a second prefix, hexacell. Ooh, that's a horrible E. It's too big of an E. Selenide, IDE. Suffix changes to IDE. Not on the first one, always on the second one. Pentanitrogen hexaselenide. All right, thank you very much for your time. Hopefully the practice is going well. If it's not, you need to go to the bottom of today's daily agenda and you need to start those practices, because this is what you're going to have on the test. You will not do well if you have not practiced. Please go practice. Thank you very much. Farewell. Bye-bye.